Feels late, right? Does it feel late to everyone else or just to me? Yeah? It's late. What time is it right now in Seattle? Midnight. So this is the midnight Azure Functions wonderful party that we're all going to have together. That's right. Happy New Year. So I'm guessing most everyone here, some of this I can jump through real fast, but I don't want to. How many of you here are already aware of Azure Functions and the whole pitch of what Azure Functions is and what it's about? I guess, who wants to hear the pitch? You want to hear the pitch? All right, we want to hear the pitch. So Azure Function, maybe I should start by introducing myself too. So I'm Jeff Hollan. I'm a program manager lead for Azure Functions. Specifically, my team works with the developers and works with customers around the Azure Functions core host and the core runtime. So the stuff that Anthony had open in Visual Studio Code that he was running, that also runs in the cloud. That's kind of the day-to-day of what I'm working on. And been working with serverless really since Microsoft kind of came out with our whole, we've got a serverless platform and it's really good story. I was a part of that kind of V team that figured out our messaging and has been pushing that ever since. So serverless is all about what I'm showing here, focusing on the code and not the plumbing. I think Anthony did a great job in the session just before us in showing you can host things in traditional ways. You could get a full-fledged, ASP.NET app. You could host it on a server or an app services, and that's fine. But there's a lot of pieces I still have to make sure I keep an eye on. Like, what happens if I need to scale out? What happens if nobody is calling my server and I'm paying for it and no one's using it? How do I make sure that this is available? How do I make sure it's patched and up to date? And depending on where you're hosting things, those questions and those answers might change. But serverless is trying to be to the far right of that spectrum as possible and saying just focus on your code. All of the plumbing and all of the implementation will be handled for you. Now today, I'm actually going to tell you a little bit about the plumbing. We're going to go look at the plumbing behind the scenes some, because I do think it's helpful, but you don't have to if you don't want to. I'm assuming if you're here, it's because you want to see the plumbing. But that's what Functions is all about. Functions fit in a number of scenarios. We see people writing Azure Functions for microservices. We see people writing Azure Functions for real-time event streams, whether that's Cosmos DB event streams or Event Hubs event streams. Big data processing. I actually just yesterday was talking to a customer here in Sydney who's using Functions to look at genetic sequencing data. So they have this massive, like gigabytes of genome and genetic sequencing data, and then they serverlessly kind of process it in a massive parallel batch at once, and then they make some analysis on those results. So big data processing, machine learning is a really common use case because you get this really rapid scale when you need it, and you're not paying when you don't. Back-end APIs, business automation, and glue. You'll very often hear Functions talked about as like, this is the cloud glue. Hey, I have Cosmos DB, I have SQL, maybe I have SAP. How do I get these things to talk to each other? And that's where I can throw in some logic apps, I can throw in some functions, get everything to play nice. When I look at Azure Functions, I'm not going to spend too much time in the creating. One of the big changes that I do want to kind of drain is the Functions 2.0 release. It's a little bit misleading. It might have been a bad move for us to make so much noise about Functions 2.0, because for the most part, everything hosts and runs the same. But we made a few changes in terms of how the runtime behaves, and it does impact users. So Azure Functions version 1 was written on .NET Framework 4.6. I think now it's, 4.7.1. That had some problems, not terrible problems, but we had users, I mentioned before I started talking today, we have a lot of users who are interested in Functions who use Macs. You can't develop on a Mac when you have a .NET Framework application. We also have customers who want to host Functions in Linux containers, and you can't run Functions in a Linux container if it's .NET Framework. So we rewrote the Azure Functions runtime in .NET Core 2. It's now .NET Core 2.1, and it's compatible for .NET Core 2.2, and we'll keep moving it up from there. It comes with a number of new trigger, binding, and assembly extensibility. So for Functions version 1, if you used it, and by the way, as I go, I started this just bursting out. If you have questions as we go, just feel free to raise your hand. Don't feel like you're interrupting me. We can keep this very informal. With Functions version 1, when we integrated with services like Cosmos, like queues, all of that code was sent as a single package with just the functions runtime. Like we had one functions runtime, and it knew how to talk to every trigger and every binding and every extensibility point. And so whenever we needed to version something, we versioned the entire runtime as one unit. That has a few problems here and there, but the biggest one, it's heavy. So if you wrote a function that doesn't need Cosmos, you're still loading in all those Cosmos libraries even if you didn't need it. So in version 2, we broke it apart. Now you pull in triggers, you pull in features as extensions, you pull in SignalR as an extension. The core runtime is very lightweight, and those extensions can be versioned and updated and improved independently as well. I'll skip key vault integration because I'll show that in a second. Container runtime I mentioned. The one that's not here that I do want to call out, along with the move to .NET Core 2, if any of you built or worked with Functions 1.0 and much, one of the biggest complaints we got, which was completely valid, especially from the .NET community, was, hey, I want to use Newtonsoft version 11. Your Functions runtime uses Newtonsoft version 9. When I try to use Newtonsoft version 11, it screams and yells and cries at me and says, oh, there's assembly conflicts and things just break. So people were like, hey, can I write binding redirects? Like, how do I get around this? And we weren't exposing that in Functions version 1. So we worked very closely with the .NET Core team, and we're like, look, is the right answer here that we let people write binding redirects? Do we do something else? What we came to the conclusion to do and what we've implemented is we have separate assembly load contexts. So we load all of the assemblies for the runtime in a separate load context. Then we load all the assemblies for your Azure function. And you no longer hit these conflicts between, if you're using Newtonsoft 11, that's fine. We'll use Newtonsoft 11 when it's in your context. And when it's in our context doing our things, we might use a different version of Newtonsoft. But they can both happily coexist now. So we don't have people anymore who are running into these headaches of, oh, shoot, I'm stuck on this version of storage. I'm stuck on this version of Newtonsoft because of what you as a team happen to be using for the runtime behind the scenes. Because you're choosing .NET, I'm somehow punished for that as a user. So we wanted to get rid of that pain. Oh, where do I want to take this next? Yeah, we'll talk about this part. I talked about how we're going to talk about plumbing, so we'll talk about plumbing. One of the challenges with serverless is that it can sometimes feel like a little bit of a black box. You send a request to a function, it spins up and runs your code and sends back a response, but you don't really know what's happening. Like, it's called serverless, so where are these things running, right? I have no idea where they're running. I have no idea how they're running. I don't even know if they're servers. There are servers, as you all know, because you're all very smart, I can tell. So what is happening behind the scenes? So in every Azure data center, we have a bunch of virtual machines that are sitting around looking for purpose in life. They desperately want to be doing something more valuable than floating around in the primordial soup of a data center. They're very sad and lonely. Our good friends in app services have heaps of these VMs floating around because people love web apps and they love to scale them. And so we look at all this spare infrastructure and we bring in a few other components. The first one is the HTTP front end or the event source. Sometimes this might be an Azure Queue, Cosmos DB. But the thing that's going to get the events. For the simple case, I'm going to just stay with HTTP because it's the most easy to follow along. So that front end's sitting there. And then we have this other piece called the scale controller. And the scale controller, I often think about this. This is the brain that decides how to run your functions and how to scale your functions. So when you first write an Azure function, like I've got a function. Oh, I'll need to change these displays so you can see. Hold on. I'm sorry. OK. So I've got a very simple function here, which is just an HTTP function, not doing anything fancy. If I take this function right now and I publish this to the cloud, we're not going to run that on any servers. We're not going to take any of these VMs floating around here and put my code on it yet. We're just going to store that in our database. We're going to put some mappings in our HTTP front end, but we're not actually running it on any servers because with Azure Functions, you're only paying us when your code is running, so we lose a lot of money if we run your code 24/7. So what happens is an HTTP request comes in. And the first thing that happens is the HTTP request comes in, and the front end looks at its caches, and it looks around, and it says, hey, this is targeted towards Jeff's function. Do we have a server running Jeff's function on it already? And if the answer is no, like it is in this case right now, we hurry, we grab one of those VMs that's floating around without a purpose in life, and we say, guess what, VM? I have great news for you. You have a purpose in life now. Jeff needs you urgently, as fast as you can. Here's his code. Get it running. We're going to send this event to you. So the VM's so excited, it gets dressed and ready for school, and it's like, I have purpose in life, and it sends back the response it does at computing. Now, after that's done, we let this VM hang around. It was so excited, we don't want to break its little heart and just throw it away right away. So we'll let it float around for 15 to 20 minutes. But if 15 to 20 minutes go by and nothing happens, like I mentioned, you're not paying us any money when nothing's happening. So we go back to that VM, and I have a heart-to-heart, and I say, listen, I'm so sorry. Jeff doesn't care about you anymore. He's not calling you anymore. You're gone. You're dead to us. You're dead to him. And that goes away, and the cycle repeats. And then another request comes in. We find a new VM. We give it a purpose, and it sends its response. And again, I mentioned that's about 15 minutes that we wait for no event. This time right here that I'm animating, where we're taking a VM, we're specializing it, is what we call it. We're sticking your code on it, Jeff's code, whoever's code it is. That can take a little bit of time, right? I'll talk some more about cold start and some of the optimizations we do to make that better. But taking a server and specializing it and running your specific code on it can take some time. So we call that cold start. We're always working to improve it. I get a big report every day in my mailbox that says globally, across all languages, across these 5 scenarios, here's what our cold start's like in every region. For .NET today, for the average app, it's about 2 to 3 seconds for cold start. With 90th percentile, I think a little over 3 seconds on the one I was just looking at this morning, and then going on from there. JavaScript's about the same. Java is a little north of 3 seconds right now, and Python's a little higher, but it's in preview, and we're going to bring that down real quick. So that's something to be aware of, though. But it doesn't hit every time. It only happens if nothing's happening on that function for 20 minutes, then we scale it down. All right, let's talk about the other side of this, though, which is, what if I don't send just one request? What if I start sending hundreds and hundreds of requests? Well, behind the scenes, this is just a server, and servers have a specific amount of capacity of what they can handle. So the scale controller is constantly monitoring the rate of events coming in, how long these events are taking to process, and if things are getting queued up, and if those queues are growing and shrinking. And it's going to make some calls on, hey, does this VM need some help? Is it about to get overwhelmed? And if it's getting a number of requests, it's going to hurry and grab more and more servers. Again, you don't have to, as a user, configure auto-scale. You don't have to care about any of this. You just publish your function and send events to it. We're the ones who are making sure that you have the capacity behind the scenes. Okay? So that's how scaling works. That at its basic standpoint, we're kind of making these decisions constantly of getting your code, sticking it in a server, running it, and scaling out. So I did want to show, some of you might have seen this before. I always like doing it, though. You can watch this happen in real time. So I published yesterday a function, and I'm going to open up in App Insights the live metric stream. And so with Azure Application Insights connected to Azure Functions, you can actually get a real-time view into what's happening both with the logs of your function, but even what's happening behind the scenes. So right now, you'll see it saying this function's offline. I haven't called this in such a long time that we've pulled it off of all of the servers. It's not running anywhere right now. So what I'll do, the first thing is I'll come in here, and that's actually not what I want to hit. Let me grab this URL right here. I'll grab the URL, and I'm going to call, and let's see how long this one takes. So I'm going to call it right now. So I'm hitting that function. It's jumping to the US2, so I might get a little bit more than 2 or 3 seconds cold start. But it looks like in about 2 seconds, I got back my response. And if I come back over here, you'll see, hey, this is the happiest server in the world right now. This was the lucky EO13ED427E2. He's one of my favorites. He loves my functions. We picked this guy to run my code. Okay? So what I want to show you, though, is how quickly, if we look at the incoming request rate, I have no requests coming in. I have one server online right here. And what I want to do, and I'm really going to test the Wi-Fi here. I've heard the internet in Australia is the best in the world, so let's put that to the test. I'm going to send a load test from my laptop over Wi-Fi to this function that's currently deployed in the Western United States. But let's see what happens. Okay? So I'm going to send 400 requests every second concurrently at this function. And what you might have noticed is that as these requests have been picking up, before I'm even finishing this sentence, I now have 7 servers that are online and processing my code. So I don't know how many of you have ever deployed a server in Azure before and clicked New, VM, and then Create. It does not happen that quickly, okay? And if it did, I would be so happy. But you can tell here we've made a bunch of optimizations to make it so now, actually this is great Wi-Fi. Congratulations to the networking team here. I'll make sure I'm not messing up the quality of the video stream as well. Yeah, congrats, kudos. But you'll see here very quickly I jumped right to 1,000 requests a second. I had a little latency here at the beginning. I'll try to zoom in before this goes away. You can see I saw a little spike here while we had to get those 7 servers. But really quick, we found the sweet spot, and that latency dropped right down. All of that happened automatically for me. The other thing I'll just point out, I stopped the load test. I still have 7 servers that are hanging around. And those are going to hang around for 15 minutes because we don't know if you're going to keep calling this or not. And so for your sake and for our sake, because we don't want to have to keep recycling servers more than we need to, these are going to hang around until I use them more. Okay? So that's a nice visual. Like you can watch this. You can see how things behave and tweak some of the knobs and watch how quickly and rapidly we're scaling you out to match the load for whatever you're sending. So any questions so far? We're doing good? Yeah, go for it. And do we need Mike still? Yeah.
What if I, by mistake, put a dead loop in my function code?
Yeah. Actually, I don't even have to repeat the question, do I? Should I repeat it for the people in the room? Yeah. Yeah. So what happens if there's like a infinite loop or some dead loop or something in my code? So Azure Functions in the consumption plan today, we limit a single execution to 10 minutes. So if something's run awry or you make some call to a SQL database and the SQL database is just hanging up, after 10 minutes for exactly these types of things, we're just going to terminate that execution. So we'll terminate it for you, and then the next one will pick up.
So would it spin up 400 instances for these 400 requests if that function had that bug?
We will. So yeah, we will compensate for some bad code. So we have people who write very inefficient code, and we end up scaling more because of it, because our scale controller, this brain, is looking at how long and how overwhelmed the instances are going. So if you write bad code, we will scale you out even more to compensate to try to get those response rates lower. We don't want you to write bad code, but it's actually, that's one of the hidden things of serverless is sometimes you can get away with bad code because you send 1,000 requests at it, and you're like, look, it worked, I have low response times, but behind the scenes we've had to spin up 20 servers instead of 7. But as a user, you're only paying for how long an execution takes and how much memory it's consuming. So assuming you have those in balance, you might actually get away with running more on more or less on more. Hopefully that helps. OK, we'll jump across for now. Good questions. Scale demo, we just did that. All right, so let's talk a little bit more about scale. So this would be a perfect world of scaling. The blue line, the smooth blue line, that would be the events that are coming in. Let's say that these are HTTP requests. And the darker line right here that kind of steps, this is the amount of capacity that we have given your application. Now, in a perfect world, we would be so smart that we could predict the future. And before I ever sent that request to my function, we would know Jeff's about to send a request to the function and spin up a VM for you and run your code on it. So when that first request came in, there was already a VM ready. There was already a server ready to process the request. And as the load keeps going, we're always right in the nick of time, predicting the future and giving you the amount of capacity that you need. So this is what we're constantly aiming for, but unfortunately we haven't cracked predicting the future yet. I've asked our development team to focus more on lottery ticket prediction, and I've taken them off of cold start prediction. But once I win the lottery, I will put them back on making it so that we can predict your cold start. So in reality, it looks a little bit like this. And this is across all serverless providers, Functions, Lambda, Google Cloud, where we get the first request, it hits our front end, it hits your queue, and then we're like, oh, Jeff needs you, and we hurry and spin up a VM for you. And then you watch this happen, we kind of proactively went ahead. And what this means is you can sometimes get those humps, like what you saw in my latency chart, where because we're trying to keep up and understand, we don't know if this is one request out of 1 or one request out of 1,000, we're constantly adapting and trying to proactively react to the right things that you need. Now, one of the common requests for serverless in general is, hey, Azure, hey, AWS, you might not be able to predict the future, but I know my workloads. And I know that on November 26th, we're going to run a huge promotion, and I'm about to get a bunch of traffic at 8 a.m. So even though you don't know, I know, is there any way that I can get more configuration options to keep things warmed or potentially scaled and advanced? So you can think of this exact chart right here, but maybe being able to bump it up, just bump it up by 1 and saying, you know what, instead of starting from 0, can I just pay a couple bucks a month or maybe a couple bucks for these few hours to pre-scale in advance so that I'm already ready for that first event, and then I can continue to do that really rapid, get me to 7 or 10 if I need it from there. So in this world, I'm not having any cold start. You can see I always have enough capacity, but to do it, I've had to kind of in advance say, let's start at 1. So previously, this has just been something that comes up from time to time in the serverless community, but has not been possible. One of the things that is in private preview today is that I can take that same Azure function that I published, the same Azure function that I just did a load test for, and I can tweak the plan settings. And I can move this over to what's called the Azure Functions Premium Plan. And one of the options that the Premium Plan gives me, which I'll open up right here to show you. Let me find one of my Premium Plan functions. One of the options that the Premium Plan gives me is that I can actually pre-scale and pay for some fixed cores to always be warm ahead of time. Because we work with so many enterprises, and some of them are like, look, we love the programming model, we love the scale, but instead of starting from 0, I want to make sure that this is warm right now. And we will give you this knob that I'm showing you right now to say, I want to warm this up in advance. And you could schedule this as you want. Now, I want to trust you. I want to believe you. But if you tell us you need 10 VMs warmed, I will warm them up, but I'm going to charge you for them, okay? Because if you give 10 VMs and then no events come and we still did the pure consumption pricing, I would lose my job very, very quickly. So we give you this option, but no, when you choose to keep something warmed in advance, you will need to be paying to keep that core warm. And for all who might be familiar with app services, right now we're looking at pricing that's 1-to-1 with app service plans. So however much you pay for an app service core, that's how much you'd be paying for one of these cores in advance. But it still scales. I could do the same test. I have the exact same function, which I have set this for. I'll just open this up for you now. So this is another function. Maybe I'll do this. I'll do this. That's fine. Same function. I just tweaked it, and I turned this on to have, I think, 2 warmed in advance. So this one I have also not called. But you'll notice here, I have 2 servers that are ready to run. Because in this case, I've said, this is an important enough thing. I want 2 of these running around. This is a mission-critical enterprise app. And I think here, actually, I can run the same scale test and change the URL from cons for consumption to prem for premium. And you'll watch the same rapid scale happen, but you'll notice that I'm going to keep this warmed buffer. I'm going to keep this core buffer so that I never hit cold start. So if you remember from the first one, when I sent those first requests, I had a spike up at the very beginning of like 500, 600 milliseconds. For this one, it looks like the very first one, for whatever reason, was like 50 milliseconds. But right away, I'm starting on the floor. And this is still scaling up. These are actually really beefy VMs, too. These are like super cored. In this case, I jumped really quickly to 2,000 requests a second. It has decided to scale up, but I have a few VMs that are on reserve ready to go. So in this case, I'm not sending a whole bunch of load. It looks like these 2 servers are able to do it. I suspect we'll see even a 4th one go. You're not seeing it scale as wide because I also chose really big machines in this case. These are like 4 cores, where my other ones are a single core. But just to give you an idea, I didn't see that hump in latency anymore. I still see the rapid scale, but I was able to, in advance, go ahead and keep this warm. So that's that. And I know there's still that weird one right there at 50, but that's like an order of magnitude less than the first one. So we'll go ahead. Yeah, there's a few questions, so we'll go ahead and answer a few.
One question. Regarding the cold start, I can write any trigger which triggers my function app for like every 10 minutes, maybe logic app, and I can still do it under my free consumption plan, right?
Yep.
So would that keep aside a VM running for, and a part of the same question is that, do you dedicate a single VM to a single user? Because I'm just actually not doing anything. I'm just keeping it alive while triggering it. I'm doing it under my free plan. So.
Yep. So it's a very valid approach. I'm sad that people have to do it. Another approach to this that's very common is I'm just going to put a timer trigger in the same app, have it fire every 5 minutes. And that firing every 5 minutes doesn't even have to run any code. Don't tell anyone this. Don't tell anyone this that this works. And don't record this part. But it's going to poke it every 5 minutes and keep it alive. And that's fine. The only thing I would clarify here is, at the very most, you're only going to keep 1 instance alive. 1 instance is all you're going to keep alive in that case. So it would almost be like if I could, oh, wow, I've never actually done this. I'm going to try to draw a line. It'd be like if I make sure that there's always at least 1 line here. but you would still have, we'd still have to kind of predictively scale out from there. So it would work for some scenarios, but it's not quite one-to-one. Because the other thing we're doing in this world, and I know I switched away, as we scaled out, we continually kept scaling out in advance. So we always had this buffer, of course. So you can't replicate that with pings today. The other side, though, in terms of, yeah, we do enforce that like your app is running in an isolated container environment that only your app is running on per customer. So we're not mixing people and throwing them, and we're like, hey, use your memory wisely, because that's not always the best thing to do as a cloud provider. So good question. Hopefully that helps. There were some other questions too.
So you were talking about the use case of having a schedule. So I was previously working for a sporting organisation, and obviously game time is the huge time, and we have a schedule. Yeah. Is there some automated way that we can fiddle those knobs that you were showing there in Azure Premium? Yeah, absolutely. So that the aspect with it today is moving between these behaviors. You do have to switch plan types, which is fine. I'm actually working on a sample right now. I might have the code floating around here somewhere on this machine. But I will post this before we go into public preview. I have a durable function. It could be a logic app. It could be anything, which has said, hey, before this time, go make this simple ARM call through the Azure API, tweak the setting, wait for 3 hours, and then go send it back. So if I don't want to pay for this core 30 days during the month, I could automate, and it's just a single call. You just make a call and you say, hey, change plan type from consumption to premium. It's a put on a single resource, and you're done. So I'll have a sample that does that in the next few weeks for that exact scenario. I think mine's going to be like on the weekends, scale it to have cold start, but on the weekdays have some. But the same idea, if you know a game's coming, so that somebody doesn't have to like open up the portal and be like, okay, when's kickoff? You could automate that as well. So great question. Anything else before we kind of moving on? Yeah, go for it.
Just as a hypothetical scenario, if it's not a badly written function and I don't want to use Azure durable functions, is it possible to move on to a plan which increases the max execution window of an Azure function from 10 minutes to something longer?
Yeah, so the only way you could do that today, if you move to this model 2 where you have this premium plan, because you are reserving VMs for you, we will let you run unbounded. So I actually think this might be my next slide. Maybe this would be a segue here. Nope, it's not one of the things. So the Azure Functions Premium plan is what we've been talking about. Prescale and always warm instances is one of the benefits. The other one is unlimited run duration, but you would have to be running them in this plan. And if you switch to the consumption mode, the pure like only pay when it runs, that limit would be enforced again. But you could just keep it in the premium mode and have unbounded. The other one that's coming with this too is VNet integration. I think one thing we've seen is, especially for us, connecting to a VNet takes some time and it magnifies cold start. And this is the case again across cloud providers. When you connect a Lambda, when you connect an Azure function, well, hypothetically to a VNet, your cold start goes up a ton because now instead of just sticking that code on the VM, we also have to switch a few wires and get you connected to your VNet. So this premium plan will let you configure VNet integration, but you don't pay a cold start penalty, which is nice. And then also, you saw some of those other knobs. I get a little bit of predictable pricing. So it's not for everyone, but we definitely work with some enterprises that are like, we want functions, but I want to budget $400 a month and this much dollars a year towards our functions. And I want to go to our CIO and get that budget approved. But today in the pure serverless model, it's like, well, you might pay $400 a month. You might pay $2 a month, and you might pay $800 a month. It really depends on how much you use. But with these knobs in premium, you could really say either, yeah, pay outright or never pay more than 400. I'm only ever willing to pay as much as 400, but scale me out within those limits. So those are all some of the features. It's a private preview today. It will be coming in public preview shortly. If any of you are interested in trying it out, we can add your subscription to the private preview through this link. Okay, so that's this. Let's move over to durable functions. How many of you here have heard of durable functions before? Oh, pretty much everyone. How many of you know how durable functions work? Oh man, pretty much everyone. All right, well, I'll do this still, but I was hoping to excite some people. All right, so let's talk about a scenario really quick. How are we doing on time? Yeah, pretty good. We'll go for like another 15, 20 minutes. Good questions, though. Let's keep that happening. If I come here to, this is an e-store. This is written by one of our cloud developer advocates, Sarah Drasner, which I just cloned and then published and gave it my own URL, which was a demo for those Azure fans out there. Corey Sanders stole my thunder. I built this demo for Corey Sanders, and then he takes it everywhere and takes credit for it. But that's okay. I take Anthony's demos all the time, and I just take credit for them. And then I hand them to Corey, and he takes credit for them. So I have a store here, and I can make purchases. And when I make these purchases, it processes the transaction and stores them in a Cosmos database. And what I wanted to build was a solution so that at the end of the week, I could go look at every single transaction that happened during that week and figure out what the status of every order was. So is this order being processed? Is this order in transit? Is this order delivered? Like, what's the process? Now, the challenge of that is if I want to do that all in an Azure function, like just a single HTTP triggered Azure function, we've already talked about there's execution limits, right? Things can be long running. If I said, go get every transaction from Cosmos, do a for each loop, and for every item, go do a lookup, I'm going to hit my execution duration, and it's not very efficient. I'm just kind of using a single process. I'm not parallelizing the work. But solving that outside of a single function can be complicated. So durable functions is a framework extension for Azure Functions that lets you write orchestration as code. So the main patterns that it provides, and I don't know why my slides, oh, I think I'm zoomed in a little bit, that's why. You can just say call like function 1, then function 2, then function 3. You can do this fan out, fan in. This is what I want to use for our order processing thing. Fan out and do like a parallel execution to look up every order process. And then when you finished everything, then fan back in. You can get external events. You can do kind of long-running, more stateful, actor-y, actor-like, actor-ish things. Long-running APIs and human interaction. Similar, many of these scenarios overlap with logic apps, and for some of these, logic apps is the better tool. But you have the option of both, and some of these I think are best suited for durable. So thinking of the scenario I just talked about, I'll just show you what that looks like in code, even though many of you know what durable is. So I'll go through this quick, but not too quick. So this is the durable function that does that order lookup that I just described. This is written in .NET. It feels like it's just one simple app, but it's doing something much cooler behind the scenes. I create an order totals list. I'm going to say, hey, get me all the transactions. Now, to get all the transactions, I'm telling it to call an Azure function in this app called durable_get transaction. So when this special function starts running, the first thing it's going to do is execute this other function. So I have down here, get transactions. This is another function. And it's going to return back enumerable of documents. So it's going to call that Azure function. It's going to get back the results. And then I have here a for each loop. And it looks just like a for each loop. Great, I know what it's doing. But I'm adding this all in a task list, and I'm waiting for all of them to complete. And what's cool here is the durable framework is going to see this pattern. And it's going to see that I just want them all done parallel if possible. And just let me know when they're all done. And it's going to execute this Azure function in parallel all at once. So it's just going to drop a bunch of tasks to be done. I'm going to get all the processes in parallel. And then when everything's completed, I can do my aggregation. And the nice thing here is this is still running in the pure serverless mode. Nothing is magically happening. We're just using event sourcing and event replaying to make this happen. So I can actually call this API right now. I think I have, again, Corey SA store function right here. And when I call it, I get back an immediate response from the function that says, call this URL to get the status, and here's something you can do to terminate it. Here's something you can do to rewind, if I want to rewind the work I just did. Let's go ahead and get the status. Right now it's pending. It hasn't started running. It's queued up. My function's probably by now spun up. So it's running right now. It hasn't completed. Right now, somewhere in the process, it's grabbed the Cosmos transactions. It's checking the status for each. There might be 1. There might be 10,000. I don't really know. And the durable framework on top of functions is managing the state of this entire process for me. It's orchestrating all of these calls to the dependent services. So now I'm going to refresh again. It's completed, and I got back my report. So in this case, it looks like I had about 25 orders in the last week. 7 of them shipped, 4 of them delivered, 10 of them other, whatever that is, and 5 of them are processing. So just an example of how I think sometimes people think functions, it's only for these stateless, really simple things. Durable is a great way to do more. I'm not even going to explain how it works. OK, let's go one more thing. This is how durable works. It's great. That's not where I want to go. OK, so the other piece when we talk about Azure Functions, where we're headed, here's another question. How many of you have used Service Fabric before? OK, that's about what OK, Anthony, good job. He's giving a session on Service Fabric tomorrow, so we better. What about Kubernetes? Anyone here done much with Kubernetes? So 1. OK, 2 or 3. So Azure Functions, whether I mentioned this or not, and I think Anthony might have, is fully open sourced. This is great for a lot of reasons. We can get issues and contributions directly from the community. Anthony contributed the SignalR bindings that he was showing in his session, all open sourced and from the kindness of his heart, which we appreciate. And that's really great. But the other good thing is about running in the open source and that we're on .NET Core now is that Azure Functions can run in all sorts of different environments. So Azure Functions can run on the 2 services I've showed you today. It can run on your local dev machine. Maybe I didn't show that, but that's OK. I can take the core tools. I can run them on Windows or Mac or Linux. I can use code. I can use containers. I can do whatever I want here and run the exact runtime. It is not an emulation. It is not a replication. It is the exact runtime that will be running in the cloud on my local machine. And I can take that code and I can publish it to the Azure Functions service. What I've just shown you, it can scale out, it can scale in, it does all this great stuff. But I go to a number of different like executive meetings, and there's a lot of Fortune 500 companies or these bigger enterprises who are saying, I like serverless, I love it for this model, but I'm in the financial industry. We have regulation that says this data cannot be processed in the cloud. So what do I do about workloads where I can't run these functions in the cloud? Sometimes my developers don't know or don't care where their code is being hosted. They just write code and hand it over to us. Does that mean we can't use serverless because we have scenarios where it might not make the most sense? So Azure Functions enables you to also take that exact code, the same app that you had written, but host it in a Docker container wherever you want it to run. So one of the pieces of work we're doing right now is some partnerships with the Azure Kubernetes service team. So that if you have a scenario, if you have something where you decide you want to run this in Kubernetes, in Azure, on premises, wherever, you can do that. Your developers can still write their really simple functions where it makes sense. They don't have to, but they can. And it's just up to you to host them where they make the most sense. Now, going back to the value prop at the beginning, obviously if you run your functions in Kubernetes on premises or wherever else, you are taking on much more of the operating costs, right? This is not serverless in the way we usually think about it anymore because I'm managing servers, I'm managing Kubernetes. And we understand that, but I guess we don't want to say, because you have some scenarios that makes sense, we're not going to let you do it. We just wanted to enable it everywhere. So that's one of the big pivots that we're making as a team, lighting up so the functions experience is still great on Kubernetes, it's still great on IoT Edge, it's still great on premises, but I'm still dealing with that single app model. The last thing I'll talk about here, maybe the last thing, and then we'll do some questions. Yeah, I think I have a roadmap slide, maybe not. No, we don't need to demo functions on Kubernetes. It works, and it's really good. I'll show you what the command looks like. I say func, deploy. I'll show you right now. So we want to make it as easy as this. This is actually in our command line today. If I'm in an Azure Functions project, I can just say func deploy to Kubernetes, point to the container registry, tell it the name of the service that I want, and we will deploy that directly to Kubernetes using the Kubernetes API and the Kubernetes command line tools. This is just the beginning of this. We want to take things like the scale controller logic and allow you to run that scale controller logic on Kubernetes as well. So that's some of the work that others in Microsoft are helping lead out right now. I don't have a roadmap slide, but some of the things that are coming that I do want to mention. Where is the roadmap slide? Maybe I do. Is this roadmap? Nope. I'll just leave it on this one. So a few of the things that we're working on right now, for .NET specifically, one of the most common asks we get is, I'll come share this code and illustrate it. I have here a logger that is being injected into this function. And your logger does some things, and that's fine. But what if I want to inject my own things, or maybe even override what you're injecting? How do I do dependency injection in Azure Function? Like, let's say I want to make an HTTP request. How could I inject an HTTP client into an Azure function? Today, we don't let you do that very easily. There's some people who've wrote some really creative extensions that help. But because we're doing public static, because we're always the one instantiating and injecting, makes it very difficult. So one of the things that should light up here in the next month or two is the ability to, for your function projects, actually create a constructor. And the constructor, what is this called? Charge stripe. And the constructor is going to be called whenever we instantiate one of your new functions. And we'll let you do things like define dependency injection mappings and do inversion of control so that you could say, hey, I want iHTTP client to be a new HTTP client. Here's the scope that I want it to have, and I'm going to use autofact to do it and all these other great things. So dependency injection's the #1 thing on the backlog right now. That even yesterday I sent another email. It was like, hey, I met with a customer. Guess what the one thing they asked for was? Dependency injection. I will tell you this. So did anyone see any of the stuff we did at Ignite back in September? That's good, so I'll spoil it for you. I got on the stage with one of our lead developers. His name's Fabio. He's awesome. Honestly, he's awesome. And he demoed dependency injection. And he said, you know what? And he was talking to me before the session too. He's like, I know how to build this. This should take about 2 or 3 weeks of work to build. And so on stage, he said, hey, everyone, by the end of the year, we're going to have dependency injection for Azure Functions. And this is like, whatever, September 30th or something. He gets off the plane when he comes home, and his manager pulls him aside, and he says, hey, Fabio, I have some good news for you. You're being promoted, and you are now a manager. And now you have 12 developers who report to you. And what Fabio learned was that now that he is managing 12 developers, something that will take him 3 weeks to do, that 3 weeks can spread out over a real, real long time because he's working with developers. So the lesson that I've learned from this is never promote your good developers. Okay, never promote them. Only promote the crappy ones, because when you promote the good ones, productivity just goes down. No, I joke, but in all honesty, he did. Like he was working in November, and he's like, no, I still want to ship this. But recently, before the break, we handed it off to some of the people on his team because he's not as much of an individual contributor anymore, which is why we're a little bit later than I would like. But this is still coming imminently, and we've got some great developers who are building this right now. So that's top of the backlog. I mentioned Kubernetes support. I mentioned the Azure Functions Premium plan. More improvements in terms of security and authentication. So key vault integration is something we've shipped that we're going to keep improving to do like key rotation. I think that's a big one we want to bite off soon. I don't know if there's anything else. Is there anything else anyone has questions about on roadmap? And I can answer if they're coming. Or something you would like us to build. This is the chance where you get to define the backlog. Yeah, Wagner, what would you like to see? This better be good.
When you're talking about key vault, is key vault integration at binding level?
Yes. So I'll show you actually what's there today. I don't know if you've seen it or used it much. But so if I come back here to this code, I need to get a few things. I have a Cosmos DB connection string. This is mapped to an app setting where I need to get a connection string to Cosmos DB. I also have a Stripe API key. Both of these are things that I really want to keep safe. I do not want a developer to have them. I do not want them checked into source control. Now, when I work locally, I might have my own, this is like a test key that I'm OK to have locally. It is not checked into source control, but I can use it in my local development and things just work fine. But what happens when I do publish this? And how do I keep those secrets safe? So if I come here to one of my functions, all of them should work. That's fine. Some of these I've configured to do this. Other ones I haven't. Let's grab this one. When I come here to Azure Functions, and I'm going to open this at the same time, and Key Vault, I can take those secrets, like those connection strings, like that Stripe API key, and I can put them into Key Vault. And when I put them into Key Vault, yes, this one's got it. OK, perfect. Sorry about this. I'm opening things up in real time to answer questions. And here's a Key Vault right here. All right, so I can put those secrets into Key Vault. And Key Vault's going to encrypt these and protect them and allow me to version and manage them separate from the code. And I can have access policies. Now, one of the things we let you do, you'll notice here, I have permission to do operations on this Key Vault because I have to run this demo. And I have made the mistake before to prove that, hey, you can stop any user from having permission to these. And I went and deleted myself. And guess what happens when you delete yourself from Key Vault while you're using the Azure portal? You really get locked out. Like it didn't let, I had to delete the whole Key Vault. I couldn't do anything with it anymore. I was stuck. So I have permission to this, but I have also, through what's called managed identities, given my function app permission to this. So this is an application. It's not a user. And I have gone into this function app, which is the one right here I opened on the side. I've turned on identity. So I've said, give this its own identity. Let it talk to Azure Active Directory as if it was a person. No usernames and passwords. And what I can do here now is I can go into those app settings where I have things like the Stripe key, where I have things like my Cosmos DB connection, binding, wherever else, without changing any code. And I can map that to Key Vault. So I'll zoom in right here. So I have said in this case, when you need the Stripe API key, or I could have done this for Azure Web Job Storage, I don't actually have the API key here. I'm saying to get that API key, go to Key Vault and go get this secret. And if any of you try to get the secret right now, I'm not even worried about it because Key Vault's going to say you don't have permission. But as you saw before, I've actually given my app permission to get this secret, so everything's going to work just fine. So I can put any binding, anything I want here into Key Vault. The thing here that I was mentioning in the roadmap is that if I went into Key Vault and let's say I versioned the secret or I rolled my secrets, we want to make sure that your apps get updated as well. So that's some of the work that we'll be doing in the next few months, is that if I update a secret, that you can roll that out as you go.
So when you resolve the app setting from Key Vault and your app's scaling out rapidly, do you cache the secret somehow so you don't hit Key Vault too hard?
Yep. So when we instantiate a new server, when we say, hey, you have a purpose in life, you're Jeff's server, that's when we would go resolve all of these, and we keep it in cache until we throw it away. So you're not, Key Vault has really strict throttles, and we would get killed if we have to go resolve this every time. So we just grab it once, and you saw, like in that case, I would have grabbed it 7 times when I scaled to 7, and then we keep it around, and so that you can keep reusing it. The only other thing that I'll mention for roadmap 2, slots. Slots is something that's in preview today, very similar to app service slots. That should become generally available and work real nice by the end of this first half. That's the goal, at least right now, so by July 1st. Unless someone gets promoted who shouldn't get promoted, and then it might be longer.
So from preview to GA, is anything going to change with slots?
Great question. So the good thing with slots today is that it works. The bad thing with slots today is it doesn't work how I want it to work. So if you're familiar with the concept of slots or not, what this allows me to do is say, hey, I have, let's say, an HTTP trigger, and I'm going to create a slot where I can send the next version of the app. On my command, whenever I say swap, it can hurry and swap those versions so that I can have like 0 downtime HTTP deployments where no traffic is lost. Now the problem today with preview has to do with scale. So if I have my app, and let's say I did exactly what I did before and I'd scaled out to those 7 instances. In my slot, I now have 7 instances. The problem though is in your development slot or your staging slot, you don't have any instances. It's at 0 right now. So as soon as you push that swap button, you're going to take all that traffic that was being spread across 7 instances, and it's going to slam a slot that's cold, and it's going to have to scale up from scratch again. So it doesn't feel very 0 downtime deployment where you push swap and all of a sudden your latency jumps up and things have to scale again and correct themselves. So the work we're doing right now is to make it so that when you have a slot and you say swap, that we match scale, and then we swap them one at a time. So that it's a very seamless 0 downtime thing, and you just keep consuming messages, and it just keeps going. And the next thing I'd like to see after this is just aspirational is, let's say we start doing some swaps and we start getting failures. Maybe we can be smart enough to be like, oh, hey, don't swap. Bad idea. Abort. So that we can make sure that we keep you safe from swapping bad code into production. Any other questions? Great questions. Great. You guys, it's 8 o'clock. It's 1 in the morning now. You're doing fantastic. I'm very proud of you.
Just one question around how Azure Functions run on these VM instances actually in the background.
Yep.
Is it possible to sort of have dedicated VM instances similar to what you'd have with app services, isolated or app services environment as they're called?
Yeah, great question. So you can run kind of on our infrastructure for you, but you can even take an app service plan and have the dedicated ones and publish either a container or publish your code to those containers, and it works the same, or app service environment. And in fact, this is a little bit advanced, but one of the things that Premium will enable too is you can take an app service environment, but you can turn on Premium Elastic Scale. So one of the challenges with app services today is it does not scale as fast as my function did. It takes 5-minute increment windows, and it kind of takes things as long as they go. We will let you turn on the function-like scaling in an app service environment, is part of the Azure Functions Premium plan. So you still have it totally dedicated, totally isolated. This is your little version of Azure Functions in your virtual network on your machines, but we'll put all the logic in there to let you scale and use those resources efficiently. So one of the scenarios that we see a lot with this is we'll go to a big company. They'll say, look, we want to use an app servers environment because it makes us feel warm and fuzzy and safe inside. But we have a whole fleet of teams who are building functions. So what they'll do is they'll buy an app servers environment, put maybe 100 workers on it, and then all of their developers will just publish to that environment, all of their different functions. And with this new feature set, we're just going to scale them as if it's like their own private cloud. It's their own little version of Azure Functions, and all their function apps are going to be allocating VMs and recycling VMs as they need to. So the developers don't really care, but the business has this completely in their own isolated and dedicated workers. And everything just works the same, Linux or Windows. So good question. Does that help? OK. Go ahead.
I have a question around the durable function.
Yeah.
So I want to understand how the orchestrator and activity works. So first thing is, how does the orchestrator know that, OK, this activity is done? Because I know that it goes to sleep. So at some point it knows that, OK, I have to, it's completed and I have to come back. And second thing, because I checked it, it's an all event sourcing. So it's all the events being logged. So and they really, really grow fast. So isn't at some point we expect that at some point they start slowing up or we get a performance hit because they keep on growing and growing? And how often does it check the whole event store?
Very good question. So I did skip over this before, but I will go into it now because I think, are we doing, if we do 5 more minutes on durable, I think we're doing OK. So I'll explain how durable works, and this will answer that, and I'll hit it too. So at the very top, can we see my screen? Yes. How do I do? If I do this, does it do like a laser pointer? No, it's progressing. I wanted to annotate my slide. OK, no worries. Oh, I think I can do it here. Watch this. If this works. Do you see this? Yeah. OK, great. So this is the code. This is my durable function. Very, very simple. I'm creating a list of outputs. I'm going to call a single function called say hello. I'm going to pass it the value world. And then I'm going to return the outputs. Now, what's actually happening behind the scenes when this runs? So you trigger the orchestrator. You say, go run this orchestration. It wakes up. It scales maybe from 0, or maybe it's already there, and it's going to start running your code. You see here, it ran that first line of code, and then it comes to this await for call activity async. And before it does anything, it's going to look at the history. It's keeping a constant log in storage, as you alluded to, of what it's been doing. Right now, all it's done is started and started. So it looks at the history, and it says, hey, I'm supposed to say hello to the world. Have I already done this? In the execution history, which is this history table, it's like, no, you haven't said hello to the world yet. You haven't done this step yet. The orchestrator's like, OK, cool. I need to do this action. So the orchestrator is going to schedule the activity function through a queue message and say, hey, say hello function. You need to say hello to the world. And after it schedules that, the orchestrator shuts down. It finishes its execution. It completes. It's done. It goes away. Maybe it scales to 0. Now, the activity function had some work schedule. So the activity function trigger is going to fire. It's going to get the data. It's going to say hello to the world. And you'll notice here the history table is being updated during every step. And when the activity is done, it drops its own queue message and says, hey, I'm done now. That queue trigger will wake back up the orchestrator. Now, the most important thing to note here is when that orchestrator wakes back up, it doesn't start from the middle. Like, there's no way to just start picking up code from the middle of a method. It just doesn't work that way. So the orchestrator, is this illustration starts, you actually see it starts from the very top again. It evaluates the first line. It comes down to the second line. And it says, OK, I'm supposed to call, say hello to the world. And this time, the orchestrator is going to go to the execution history. And it's going to be like, hey, have I already said hello to the world? And here I have, right? Like, I have a record that's like, yeah, you did this step. You already did this one. So orchestrator says, cool. It doesn't do anything. It doesn't schedule any work. And it moves on to the next line of code. Now, if I had a very complex orchestrator, this could repeat itself many, many times again. But really what's happening is you have a bunch of queue-triggered functions and this history table being written in storage that do it. So to your other point, because so much data is being written and read from storage, you can hit performance limitations, specifically on the storage account. Like if you have multiple orchestrations all sharing the same storage account, you can start getting throttled. It can take a long time to read all of the history. So there's a lot of best practices about try to keep your history table short. Don't write infinite loops. I know that sounds funny because it's like never write infinite loops. But like don't have a durable function that just constantly repeats because your execution table is just getting bigger and bigger and bigger and bigger and things get overwhelmed. So there's a number of best practices there. There's a really big doc to help get the most out about making sure that you're only using that storage account for durable. But another thing we're working on too from a roadmap perspective is allowing you to use other state providers to manage durable. So there was a hackathon recently where someone was using Cosmos DB as the backend. Same behavior, but Cosmos DB, which has a little bit more control over scale. There's some work underway right now to use things like Redis cache. So if you wanted to use durable on premises with a Redis cache, that's possible too. I don't have a timeline on when or if, I don't know if Cosmos DB is going to ship anytime soon. Redis is a little bit more immediate. But it is something to consider. And it's important to remember too, I'll just leave this slide up here, I won't drain it all. You need to make sure that you realize that this is using event sourcing and event replay. So if I had an if statement that's like if datetime.now is foo, every time that code replays, datetime.now is going to be different. And so my code can start to act erratically between each replay of the code. So you have to make sure your code is deterministic. It has to replay the same every single time. So we give you some tools, like we give you a, hey, here's durable orchestration context.current UTC datetime, which is a way for us to get time where we'll give you the same time every time it replays. I mentioned don't write infinite loops, don't do I/O. Any of these things, you just need to make sure you're aware of them from a perf point of view and from a, we need to make sure all the replays are deterministic. So good question. Another 5 minutes on durable. I think that was fine. Yeah, we'll go with maybe, one more.
Just expanding on what you just said.
Yeah.
Do you actually need to replay the code, or wouldn't you know, like you should know like what was the last line of code was executed, and you should know like all your state and all your stacks and so on. Couldn't you just save that in memory or storage somewhere, and then when you need it, instead of like having to replay everything, you just load that very last instance.
Kind of pause in almost some ways?
Yeah, or you're just saving your state, and then don't you just...
So more or less, it is kind of saving the state, and it's rehydrating its state from looking at the history. I think one of the challenges with durable is like, I may have like, I wrote a durable function once that was send me a text message for a specific alert, and then wait for me to respond back with the text. Sometimes it might take me an hour to respond back with a text. At that time, if you remember back to the scale thing, the server that started has already been blown up. It was past 15 minutes. We threw away that server. There is nothing around anymore that's running my code. So we had to build this in a way that assumes that every time that orchestrator wakes up, you have no guarantee that you're going to be on the same VM. We might have to pull a new VM. This might be a year later. This might be a week later. It might be a minute later. So we built this in a way that it's completely independent of any dependency on the actual hardware itself where it's running. So good question. Hopefully that helps answer some of why it works that way. I mean, from a behavior standpoint, we're doing that, but we end up having to we keep this history log so we can replaying it to exactly where we were before. And you can see that in logs too. I won't do it here, but if you open up your storage account when you run durable functions, you can find the blob table, you can see the queue messages, you can watch everything happening. We don't recommend it for like debugging, because there's no guarantees that you're not going to screw something up, but you can watch it happen and then use logs and such. So durable is great. Also, I'll just note this too when I say open source, durable, like 20–25% of all new durable features are actually contributions from people outside of our team. There's a really good community effort around durable, which is really exciting to see. People get really excited about it. In fact, just recently there was someone who tweeted over the weekend, it's a little bit irreverent, but this is Australia, so I might as well go for it. And they said, I spent the weekend learning durable functions. This is the greatest thing since baby Jesus. And I just laughed because there are so few things in the world that we work on in Azure where somebody's like, Azure virtual machines are the best thing in the world since baby Jesus. Like, it just doesn't happen. But people really get excited about durable, and there's a really good community around it. So that's fun to see too. Great. We'll go with one more question. I'm already here. Watch, by the way, as soon as I stand up, I'm just going to boom. Have you seen like those videos where the marathon runner gets to the finish line and then their body just shuts down? That's where I'm at right now.
I'll try to be quick.
No, you're fine. I really...
So if in durable function, I have a call to another function, it essentially can pose down the function the hosting function, right? If I have 2 calls to the functions, right, I have a chance that it will be replayed twice, right? So it first will call first function, right, and will suspend, and then this function finish up, it starts replaying, right, come to another one, and then calling it out, pausing, and then once it's finished again, replaying. If I do some activity like I.O., like I'm logging something or do some debugging message for myself, right? That message would be produced twice in that scenario, right?
On the replays, you mean? Oh, yeah, yeah. So if I understand right, it's like instead of having this simple example that I had, let's say I have 3 other lines, which is now call this one, and am I going to call say hello world every time I replay? Is that kind of what you're asking?
Yeah, yeah. And between these function calls, you put some like debug into some service, right?
Yeah,
to see what's going on, right? Telemetrics or whatever. And this outgoing call would happen on each replay, right? So how would I know that I'm in replaying mode? Do I have some state for stateless functions?
Yeah.
Or what?
Yeah, no, it's a very good question. So the one thing to clarify here is the only code we will replay is the code that's actually in the orchestrator. So we won't execute your functions again. We'll skip over that part. We won't actually replay the functions you're calling again. We'll just replay the code here. Though, if you did need it through the durable context, I believe that there is a is replaying flag where you can know if this is a replay of where it's hitting this line of code or if it's the first time it's run it. So in the orchestrator, you can actually be aware, is this a replay or not through this Boolean that I'm just dropping right there. Oh, I screwed it up again? I'm sorry. Thank you. I was showing you some stuff. I'll show it to you now. So here, back over here, you can see this now, yeah? So in a durable thing, I can say, is replaying or not? This is a Boolean. And so I could do some logic here to know if I'm replaying. Maybe I care about that and I might do something else. But I won't actually execute the functions again. I'll only run the code in the orchestrator. And the orchestrator is smart enough to not call the functions twice.
Not quite exactly what I was asking.
Okay.
So if I have below that call to that function,
Yep.
say, copy this line again. So you'll have 2 calls, right? So this is the first line.
Yep.
You call in, and you do exactly the same call down there again.
To the same function with the same
function
data?
Or a different function, doesn't matter, yeah. Just you do.
Oh, I see what you're saying.
Again.
Is there a way to pass that down to the activity so it knows, well, the activity will never get replayed. So you would never really need to check if it's a replay.
The function call itself would not be replayed because it would just read it from the table, right? And just get the data from that same, I called it again. Then it will go to your next line and say, I didn't call this function yet.
Right.
And it call it again. And what is happening, when it's come to the second call to that function, it have a replay at that point, right? And I do some I.O., I'm like logging somewhere, right? And then it finishes up, and I'm doing that a replay and logging again. On the first time, it might be not replaying, just logging something out, some message out, like message would be, I have started execution, right? And on replay, it would say again, I started execution.
Okay, I got lost. Go ahead, give it a shot, give it a shot. Okay, yeah.
You got an activity function.
Oh, Mike.
You got an activity function A,
yeah,
and you got an activity function B.
Yeah.
And in between, there is something which is not activity, which is a log thing. I'm logging something in Cosmos DB or something.
Like in my orchestrator code.
In my orchestrator.
Okay.
But so he's asking that if it's replaying, is it gonna so first time it replays the first activity function A, then there's a line, then activity function B. So when it's running, and when it's going to replay, is it going to replay that part?
Yes,
Cosmos
it will
DB?
write the log twice. And the log, right. Yeah, it will write the log twice. For logs specifically, because logging is there, in the logs, we let you know if it's a replay or not for the logs itself. So if you go look at the documentation, like all of our filters will say, filter out your logs to only show non-replayed logs. But yeah, that's why don't do I/O in the orchestrator, because we would run that twice. We would do those logs twice.
You can have something like a state.
Like reading something from files or storage or something else.
Like when you do reply, you can have like some state. I can write and read.
Yeah.
So when I'm logging, I could write into that state that I just made it log.
Yeah, and the state comes back too.
And I can say, if I'm replying and I already wrote to this log, don't do this writing. Something like that.
Like we will give the state, like in this case, I'm getting back a list of transactions. That transaction state I'm going to carry with me every time. So you don't lose any state, we replay it. Just as long as you do everything in your activity functions, you can use them however you want in the orchestrator. But just make sure you only do the things that you don't want replayed as functions. And then the framework itself does the smarts to make sure you don't. But it's not like all of these are returning void. They're returning rich state. Like in this case, I'm returning an enumerable of Stripe charges. I have access to that down here. I can say, do something else with that state, and it's still going to be there. But we're not replaying it every time. We just grabbed it once, and then we rehydrate that state every time we pull back up. Make sense? I think so. We can chat afterwards too. So
what you're doing is storing the result of that function inside the table.
That's right.
And grabbing from the table. So even if you're doing the assignment again, you're going to be writing the code up at that point. You just don't execute the function.
That's right. So all the responses do have to be serializable so that we can serialize the state and rehydrate it. So if you couldn't serialize like a binary object, you would need to serialize a reference to a blob or something.
A way to avoid that idea, especially if you're talking about the logs, is inject the logs on the called function.
Right.
So start and end should belong to that function because it's only going to happen while it's executing.
Yep. Cool. All right, so we're going to call it from there, 8:22. This has been really awesome. Great questions. Thanks to anyone who's watching this online. Yeah, thanks very much.